All right, turn your books to page 418. We're going to be going through examples 3 and 4 today out of the book here. So we're going to talk about interior angles first of what we call a regular polygon. And then we are going to talk about exterior angles right after that. So we're going to kind of review a teeny bit of what we did on Friday of last week, somewhat. And then we're going to head into exterior angles. So the first thing we're going to talk about is interior angles of a regular polygon. Now, what we did on Friday is this. We did examples 1 and 2, which talked about finding the interior angles or the sum of the interior angles. And we learned that to find the sum of the interior angles of a polygon, we need to subtract 2 from the number of sides the polygon has, and we multiply that by 180, and then that gives us the degrees. So, for example, a 7-sided figure would have 900 degrees in the interior angles added up, the sum of the interior angles. Okay. We also found a missing angle when we had all of the other angles and we were missing one. This 6-sided figure should have 720 degrees in it. We added these 5 up. They came up to be 607 degrees. So therefore, we know that this angle here has to be 113. So we just subtracted that from 720 and we got 113. Remember those from Friday? Sum of the interior angles and then finding the missing angle. Okay, find the sum first, then subtract what you know, and that'll give you your missing angle. Now, today we're going to talk about a regular, say, octagon or a regular polygon. We talked a little bit about regular the other day. Regular means all of the sides are congruent and all of the angles are congruent. So if we have an octagon here and we want to find the measure of one interior angle, just one of them, and it is a regular octagon, I know all of these angles are the same. They're all equal, okay? So the first thing I have to do is find the sum of the measures of the angles inside the octagon. So that's the first thing I do. I take 8, subtract 2, and take 6 times 180, and that gives me 1,080 degrees. So I know that the octagon should have 1,080 degrees in it. Now, if I know that every one of these angles, all 8 of them, have the exact same degree measure. So now what I'm going to do is I'm going to divide 1,080 by 8 because they're equal. So they're 8 divided, 8 equal angles. So I'm going to take 1,080 divided by 8, and that should give me my interior angles individually. So each interior angle in a regular octagon should measure 135 degrees. All of them, because they're all the same. If I don't have a regular polygon, it's hard for me to tell what the degrees are, okay? Unless I have all of them but one, like on example 2. So the measure of an interior angle of a regular octagon is 135 degrees. All of them. Each one of them is 135 degrees. So anytime you have a regular polygon, you can find the measure of a single angle by finding the sum and dividing that by how many angles or how many sides it has. Questions on that one? Okay, do number 4 on the bottom of page 418. Find the measure of an interior angle of a regular polygon with 12 sides. So if I have a 12-sided figure, find the measure of one of the angles if it's a regular polygon, a regular 12-sided figure. First, you got to find the sum. First, you got to find the sum. How many sides does it have? Okay, so put 12 in for n. 12 minus 2. And once you get that number, the sum, then divide that by 12. Once you get your sum, then divide that by 12. All right, so the first thing we need to do is find the measure of the sum of the interior angles of this 12-sided figure. So the first thing we're going to do is we are going to take 12 minus 2 and take that times 180. The number of the sides of the figure minus 2 times 180 will give you the sum. So 10 times 180 is 1800. Then we need to divide 1800 by 12 because it has 12 angles or 12 sides or both. And we need to divide that by 12, which gives us 150 as an answer, which means each angle should be 150 degrees. So find the sum of the interior angles, then divide it by how many angles it has. Because remember, a regular polygon has equal angles, or each angle, I should say, is equal. All angles are equal. All right, let's look at a picture here first. All right, we have, if you look at page 419, we're going to talk about exterior angles. The exterior angles add up to 360 degrees. If you look at these three diagrams here, and you look at the angles at each side or at each outside angle, exterior angle of, say, this pentagon here, and you took them all off or cut them out, and then, shaded them, cut them out, and you put them all together, they'll all fit right in here nicely in a circle. They'll all fit in there for 360 degrees. So no matter how many sides you have, no matter what type of polygon you have, the exterior angles will always add up to 360 degrees. Always. Of course, that means the more sides you have, the smaller those angles are going to be, right? The less sides you have, the bigger those angles are going to be. Like a triangle has really big angles on the outside, doesn't it? Okay. Whereas a square has a little bit smaller angles. And a pentagon, in that case, has a little bit smaller angles. And a hexagon, and a heptagon, an octagon, all of the above. So those all have smaller angles. as we get bigger, because the sum of the exterior angles is always 360 degrees. So we have a theorem here, theorem 8.2. It's called the polygon exterior angles theorem. It says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So again, this is a pentagon. If we add up 1, 2, 3, 4, and 5, we should get 360 degrees. Notice how small those angles are. A lot of them are acute, or almost all of them are acute. A square would have four right angles, it'd be 90, 90, 90, 90, that which add up to 360. So these are going to be a little bit less. Hexagons will be a little bit smaller, so on and so forth. Okay, so remember the exterior angles always add up to 360. These don't change like the interiors. All right, find the measure of an exterior angle. So since we know that the exterior angles of all polygons add up to 360 degrees, we know that these four angles in this picture here, since they are exterior, should add up to 360 degrees. So I'm going to add those four together, set the sum of the measures of the exterior angles, and I'm going to set those equal to 360 degrees. And now I'm going to add what I can. So 95 and 85 is 180, and 2x plus 1x is 3x. And now I'm going to solve from here. Subtract 180, divide by 3, and I get x is 60. Now it's not my answer. I need to know what, oh wait, that is my answer. Sorry. I did want to find the value of x, but if I wanted to find these two angles, I could now. This one, of course, is 60 degrees, and this one's 120 degrees. Notice in a four-sided figure, you got some pretty big angles there. 95, 85, 120 is a pretty big angle. Okay, so in a four-sided figure, you're going to have some bigger angles because you got to add up to 360. Let's look at another example. Let's say we had a figure that looked like this. Excuse me. Excuse me. Now, how many degrees do these three angles add up to? They add up to 360 degrees. Remember, the exterior angles of a polygon always add up to 360 degrees. So we're going to add these together. 8x plus 9x plus 105 degrees. And that's going to equal 360. Or it has to add up to 360. 8x plus 9x is 17x. Subtract 105 from both sides. Divide by 17, we get 15. So x is equal to 15. That would be our answer. Now, if we wanted to find these angles, we could always do that too. Whoops. For example, if we wanted to know what 9x was, we would take 9 times 15, which would equal 135 degrees. And then we would take 8 times 15, which would equal 120 degrees. So we have a 105, a 120, and a 135. And if we wanted to check that answer, we could. We would add those three together, make sure they add up to 360, which they do. Questions on that one? All right, then I would like you guys to do numbers 5, 6, 7, and 8 on page 420, please. Do numbers 5, 6, 7, and 8 on page 420. Find the value of X. Remember to look at your theorem 8.2 on page 419 if you're having trouble with the exterior angle theorem. All right, let's take a look at these. First one, we need to add those angles together and set them equal to 360. So we have a 46-degree angle. We have a 73. We have a 90. We have a 60. And we have X. Those four added together give us 119, 209, 269. Does that sound right? 269. Whoops. And then we subtract 269 from both sides. And X is equal to 91. Number 6. Again, we're going to add those together. So I have an 89, a 92, a 116, and a 3X. Set those equal to 360. 89 and 92 is 181, 281, 297. So I get 297 plus 3X equals 360. Subtract 297 from both sides. 3X equals 63, divide by 3, and X is going to equal 21. Here we have 110 plus X plus, plus X equals 360. And now we are going to add our X's together to give us 2X and subtract our 110 from both sides. We get 2X equals 250. X will equal 125. Again, divide both sides by 2. And our last one, we have 70 plus 65 plus 75 plus 3X plus 2X equals 360. 70 plus 65 plus 75 is 210. 3X plus 2X is 5X. And now we can subtract 210 from both sides and divide by 5, and X is equal to 30. So again, remember, add them all up, set them equal to 360, simplify before you start solving that equation, add the like terms if you got any. Like number 1 or number 5 there, you didn't. You just added your numbers, subtract from 360, and that was actually your answer. Number 6, you had to add them together, subtract from 360, but then you had to divide by 3 because you have 3 X's, not 1 X. Number 7, you had to combine some like terms. And number 8, you had to also combine like terms all over the place on that one. So questions on any of those? Okay, then I don't have any more for you. The rest of the time is for you to use on your assignment, 21 through 25 and 33 through